Hi everyone, Tim the Planeman here and welcome to Plane Time Redback Spider edition. Look what we've got here. It's a drone. This is the Hexsoon EDU-650 and right here on top of that EDU-650 I have mounted a Cube Red. This is the latest CubePilot flight controller. Separate video about that, check it out in the description. I think it's that side, but there'll be a link, and I'll put a link in the description as well. Introducing the Cube Red. Now this drone is a kit. It's Hexsoon, which is a partner of CubePilot, and they very kindly sent me the Hexsoon EDU-650. Oh, the name just runs off your tongue, doesn't it? I'm not going to call it this EDU-650. This is the Redback. This is the Redback Spider. This is like Christmas. I want to get inside this box and see what's in here. Wow. Oh no. Oh no. Oh no. What am I going to do? Okay, CubePilot and Hexsoon work closely together. This is an EDU-650 quadcopter. So what does that mean? Do you know what that means? Tim the Planeman, this guy here, is going to have to fly a drone. And not just like an RQ-7 plane, remote controlled plane that's a drone. This time I'm going to have to fly a quadcopter, a multi-rotor, well, what a lot of us call a drone. Tim the Planeman, what am I going to be now? Tim the Planeman becomes Tim the Drone Man? Oh no! Or oh yes. I mean, I have to say, I love new things. I love being pushed. I love trying new technologies. I love getting out of my comfort zone and trying something I haven't done before. Well, this is definitely going to be something that I haven't done before. And it's not just a cheapy $100 drone off AliExpress or Amazon that you can fly in your living room. This is a real ArduCopter drone. Okay. Wow. Ooh. CubePilot ecosystem. Look at this. Okay, well, we'll have to go through this a little bit. So what we have here in the middle, we have a Cube flight controller that is going to be a Cube Red. Here we have a HERE 3 RTK GPS. Well, guess what? We've got a HERE 4 RTK GPS. Optical flow is an option. We're not going to use that. And we've got power distribution board and LiDAR and telemetry. We'll run ArduPilot as open source. And then what we have in here is we have a drone. Okay, and this is quite the drone, people. This is, I mean, look at this plate that is effectively the fuselage of the drone. Well, let's take a quick look at what we've got here. These are legs. This will be basically for the drone standing up. But look at that. I mean, look at how high, I don't know if you can see that. Look at how high that will be with those legs. That will be the legs of the drone, and this is the frame of the drone. So we've got some drone here, I tell you. Let's see how the arms look, because this is how this drone is going to come together. This is, and look at the fancy arms for the drone. They're not round and they're not square. They're actually aerodynamically shaped drone arms. So this is the main plate for the drone, and these are the arms. Now these are all the bits and pieces to put it together. These are all the cables, these are all the attachments, the screws, the clips, and all that kind of thing. That's there. And here we have the motors. Let's have a look at the motors. Here's one of the motors with a nice long cable. Bullet connector is already attached. So that's going to run out from the arm into the center. I'm not really going to do a build video of this. There is an absolutely excellent series of videos by Andy Piper from the ArduPilot dev team online already. I'll link to his playlist on the description that explains how to put this entire machine together. I will be following his video step by step. And what have we got here? We have propellers. So these are interesting propellers because they are. I'll take one of them out so you can see this. It's the first time I've had one. These are collapsible propellers, commonly used or often used on, for example, on gliders, because they flip out of the way when they're not required. Well, that's what we got here, so that it can be, so that the drone can be packed away. But these beautiful, look at those propellers. I mean, they're like 37 centimeter long propellers, and they're collapsible, so they'll collapse down for packing away. And we have four of those, two sets of two. Okay, so what you need to see now is how this is all going to go together. Here we have the Cube Red. Now, I've got an unboxing video for the Cube Red. You might want to take a look at it. I'm going to go through the Cube Red in detail. This Cube Red is still pre-released. By the time I build this and fly it, may well be a released product. But this Cube Red has two H757 processors in it, and it has an Ethernet connection. So if all goes well, I might be able to take this Ethernet connected H757 flight controller and this Raspberry Pi, and if I am careful with how my cabling goes, I should be able to fit all of that into this drone, so that I've got basically a flying computer. More than one computer, a flying server room, because with the combination of the Cube Red, the Raspberry Pi 02W, and the Here 4 GPS, there's enough power in this little package to take Apollo 11 to the moon probably 10 times over. The capabilities are incredible. So what I'm going to do now is I'm going to build this. I'm going to build this EDU-650 drone, and I'm going to get ArduPilot. Well, I'm going to get ArduCopter running on this flight controller. I'm going to set it up with Ethernet. I'm going to connect in the GPS, and pretty soon I'm going to fly this. So I guess I better get the simulator out and start practicing how to fly a drone, how to fly a quadcopter. This is going to be obviously a quadcopter, 1, 2, 3, 4 motors, and look look at the size of it. I mean, this is not a little drone. This is definitely not 250 grams. The size of that, I mean, that's 600, 700 millimeters, I think, end to end on the rotors. This is quite a machine. Look at it, Cube Red right on the back. I've also got a Raspberry Pi companion computer mounted here and connected to the Cube Red via this Ethernet cable, and it all works. I've also used, just for now, Express LRS connected to telemetry 1. That gives me basic radio control signal with my trusty TX16S Express LRS edition. So it only runs Express LRS. There's some more to come about the Cube Red. there's 2 flight controllers in here. There's some interesting discussion about exactly how you get those things to work and provide redundancy and additional processing and stuff like that. For now, I'm just going to get it to work. This EDU-650 kit is explained in detail how to explain it by how to install it and set it up in this excellent series of videos. Again, I'll provide a link in the description. Andy Piper from the ArduPilot dev team has a complete set of videos explaining how to set this up, put it all together, and get it to work. So there's really not much for me to explain here. I'm just going to quickly touch on is how I physically put it together. This seems to be a bit of a challenge with this kit. I've come up with an idea. I think it's cool. It seems to work. All the good stuff is in Andy Piper's video and my other video that talks about the Cube Red itself. But stay tuned, because after I get this working, connected together, there will be, I'm going to fly, and this will be Tim the Planeman flying a drone. How's that going to go? Well, stick around, stay tuned, like, subscribe. Think about becoming a member of my channel. Membership is purely about whether or not you think you want to support what's going on here with Tim the Planeman. So on this Redback Spider drone that I put together following the great instructions from Andy Piper, there's an interesting problem or challenge about how to mount this top plate here. So this is, hopefully you're getting this from the top video. The top plate here is supposed to screw on to these mounting blocks here. The challenge is how to kind of screw them all in together when it all has to come in one piece, and you really want to be able to get, as you see here, all of the top electronics connected to all of the bottom electronics, and it sort of all feels like it has to come together at once. So I'll tell you what I've done here, and we're going to see if this actually works, is I bolted the arm mounts to the base plate first, as you can see, and then just to get everything working, you can just clip the top plate into those bolts. Now that's not going to be secure for flying, but it actually works great for putting everything together and getting the wires out, because you can always just pop that off if you need to get inside and see, oh, where's that wire going and what's that got to do here. Get the ESCs bolted down nicely, zip tied together. Okay, so that all works. Now, okay, so now how do I screw the top plate together? Well, here's my cunning plan. So I take all the bolts, all the inside bolts off, because what I've actually done here is I've mounted these bolts upside down. They come in from the underneath to make this work. The intention is, the design is that they actually mount from the top and then get bolted in from the bottom. And I'm not sure if I'm going to continue to do that, but what I need to do now is I need to basically remove the bolts, the nuts on the inside bolts, and then I need to screw in the outside bolts in each case, and then I'll finally finish by putting the inside bolts in. So let's see, so that the whole thing doesn't fall apart halfway through the process. So let's see how that's going to go. This is the tricky part. What I want to do now is I'm going to basically start assembling this by putting, how's that going to work? I'm going to have to bolt. So in order for one piece to work here, I'm going to have to brace this from the underside so it doesn't just fall apart. And interestingly, yeah, there we go. Okay, with the battery underneath, that is about the right size. So now I'm going to start from this one here, partly because it's got the regular nuts on it and partly because it's closest to me. if I don't put the side panels in now, then I will have a problem. So they've got to go in next. So let's get those. So these are the beautiful looking side panels. I'm going to be mounting one at the front and the two side ones. But as you can see on the back, I've got my my battery wire cable popping up the back there, and unless I cut this, which I don't want to do at this point, then that's not going to fit. So I'm just going to slot this in here, and guess what? So what I've done now is I've just cut a little slot in the middle of this so that I can slide the battery cable through there. Just makes it look so much prettier. So now I'm just going to try and slot that together without breaking it. Goes in there, and what I need to do is first of all get this end in. Slide that bolt through there, and that clips in. Why is that not coming together? There we go. Okay, I just need a nut. Hold that in. This must be what Andy Piper is calling a bit of a faff. I know that faff is an English expression, so I guess they own it, but honestly I've never heard it used like that. I've heard of faffing around, which is like in Aussie terms stuffing around or screwing around, faffing around, but I never heard of a faff used as a noun until Andy's video. Well, I guess you must know. Comments in the description about the use of faff. It's a bit of a faff is what Andy said, and I just never heard that before. Now right now I am on the edge of saying that this is faffing around, but I don't know, it still feels like an approach that's more on the side of, okay, so that's of mechanical rather than just screwing around till it works, which is what I think I would call faffing around. Well, here we have it. Here we have a fully assembled Redback Spider, aka Hexsoon EDU-650. I just love the idea. Redback Spider, Cube Red, Raspberry Pi. What else have I got? Oh, okay, just to finish. Okay, see, assembled here. We got our nice little walls now on the drone. All the electronics are encased in here, except for the flight controller itself on top. We've got Raspberry Pi connected via Ethernet. We've got a GPS and compass connected by CAN. We've got Express LRS connected to telemetry 1. Over here I have power for a Raspberry Pi, power for a Runcam Thumb Pro to be mounted on the front, and I do have underneath here a mounting for a HD0 VTX, which I'm not going to put in right away, but I've run all the wiring for it and tested it, but you know, until I get it in the air and make sure it doesn't throw itself around and break things, I will fly it without the VTX but with the Runcam Thumb Pro, so we get a little bit of video. Next video will be Well, we'll see. I might do a video about the setup. Setup is pretty easy. There's no reason to do a video. Look, the ArduPilot dev team guys have done a great job of this particular drone. There's a bunch of information on the ArduPilot wiki, links in the description, and in particular, there's a complete set of parameters, because I guess of the work with Andy Piper and Randy have done. So it's pretty straightforward to just load in the parameter file, which gives all the basic setups that you need for the drone. I have done my own motor test, but it turns out that the min spin is 16. It's actually 14, but you set it 3 higher than the number you find according to the docs. So set to 16 and 19 for the spin arm is 3 higher than you find, so it's actually 16 and 14, and so I've used 16 and 19 for my min spin arm and my min spin values. I'll put that stuff in the description if it's not clear as well. And there we have it. The Redback Spider drone. Tim the Planeman, over and out.